Now, I was figuring, since I do enhanced mod, obviously, I guess, the people want basic stuff, or...
Well, I'd like to know what the difference between enhanced and basic stuff is. I didn't know that there was a difference until we started this conversation about this topic.
Yeah, all right. Well, I've got... Basically, in this area here, I've just downloaded everything that's on the PCM hacking site, so I'll just run through that, I guess. And then, yeah, get some... Anyone got questions along the way or whatever? Yeah, I'm guessing Camtasia will record audio as well. Record audio, yep. Oh. Right, so everyone good if we start off?
Yep.
Righto. So I guess the PDF at the top that everyone either misses or does look at, it's just the README, I guess, for enhanced mod. So the crux of it all is that we know we run out of either the metering of the MAF or the software code doesn't go any higher than 256 grams per second of airflow. Or your MAF, you max it out past 10,000 hertz. Some of them make it a bit further, some of them don't. It seems to be hit and miss whether you get any further or not. But
is that purely relevant to turbocharging and supercharging? Could you
I think
those figures with the naturally aspirated engine?
No, it'd be pretty hard, I'd say. Some of the other Dick might be able to comment more on that, or some of the other tuners might have an idea, but I mean, you'd need a pretty lumpy camshaft to get up near there, but 9,000s are possible on an NA, like 9,000 in that range for the frequency. No, basically, like a lot of people say in general on a stock engine, 10 pound a boost on an L67 is sort of, you'll be pushing the stock MAF to its limit.
Mm-hmm.
So yeah, that was my first goal when I did enhanced mod. That was really all I set out to do, was to play with that, and we've got it to that. Now basically 16,000 hertz is the hardware limit. It just, you can feed it more, but it just, the circuit itself and the hardware doesn't support reading anything higher. Now the 510 grams per second, that wasn't too hard at all, because Holden actually put that in the code. They just limited it to like an 8-bit item instead of a 16-bit item. So the whole MAF bit itself came fairly quickly. The cylinder airflow on the VT and up for 850, that was the other limiting factor. And there was another guy that wrote the code on there. I just can't remember his username right now, but he wrote a bit of code and helped me out and got, so now we've got to the maximum of 1650, and I think the actual theoretical limit, because it's based off, one of the items is off crank, to work out milligrams per second of airflow. I think it was off the 8x signal on the crank, as well as the MAF airflow. But yeah, so 1650 is what we've got now, and it works good with the two tables, obviously. With the 17 rows, that's just like the, I think it's like it's the routine, the lookup routine for the 68 HC11. It's just the routine does 17 rows or columns. So yeah, that's the basics of Enhanced Mod really, and then the rest was just tweaking it up. So it's based on, before I even did any of that, the actual base bin was VL400's real-time bin. So VL400 made the NVRAMs for the VT to VY. So that's the base of the bin that I did the mods on. So out of the box it had real-time support, and then it got the MAF, and then it got the cylinder airflow increase, and then I went looking at other things. So there's the two spare 0 to 5 volt, 0 to 255 count inputs on the ECU, whatever you want to feed to that, wideband or map sensor, or whatever you want to monitor in the data stream. And so yeah, these things here are all the other features that you've got, and then basically going down through the page, it just lists out each of those features. So I tried to make it a bit easier. So EEI is extra ECU inputs, and it lists that on the website under each model, so that you know where we're at with each model and what features it's got in it. So is this heading in the right direction? Everyone's... Yeah?
Good.
So yeah, extra ECU inputs. I don't think I need to elaborate on that too much, do I? Everyone knows what an input is and what the range is up there.
Mm-hmm.
Yeah. It just comes blank in the ADX log file, so you have to go and put your own calc in for whatever you want to use it for out of the box. And then there's the generic calcs there just to help people out as well. So real-time support. And the next one was CAL, Knock Active Loops Monitor. So basically I just took within the actual factory knock code, and I think this is in 12p as well, I'm not too sure. That shows how much I use 12p. But basically it's a rolling counter, so it's just like an input, 0 to 255 counts, and then it goes back around to 0 again, but every time the part of the knock code, the first part of the knock code I think goes through, and then when it triggers above a certain amplitude, this will then cut in and increase the value by 1 on that code loop.
I think that's in 11p but not 12p.
Okay, yep. And the other thing that's possible too is there's a raw knock value in there from the factory as well, I think. I haven't quite narrowed that down yet, but that's possible to put into the data stream as well, but how useful that'll be, I don't know. It's probably not going to be quick enough to log that and see a spike in the reading anyway, which is sort of the original idea of this. If it's a rolling counter, well then you definitely, usually when you get some knock, it rolls 2 or 3 counts, not just 1. So you're going to pick up the packets even if you do miss a packet with the knock. So so there's a demo on each one of these, so you can see that it's gone up. It's picked up 2 loops of the knock code before it pulled out 1 degree there. What else have we got? Second example. Third example. So the other one was injector multiplier. So that's pretty easy. It just reads the current. It's just a straight reading of the RAM variable for what it's reading out of the injector multiplier table. So in that spot I mean, you could get the same thing by just replaying the log, moving the bubble over the table as well. But there was a few people that asked for that. And I guess if you want to go back on your logs later on and you inject them on tables of chains where you can see I used to have a value of X for that spot on the injector table. Adaptive spark, well, that's one thing that's already in the factory, but there was no actual monitor value, so you couldn't see whether it was actually working or not. I haven't added that into the V8 ones yet, but that'll eventually happen. So I think that's fairly self-explanatory. We can go through Tuner Pro later and have a look at that and how that works. Wideband versus AFR, I think we all know that, so it just calculates the difference. So you can log that out to a history table as well, and then you can use that in an Excel spreadsheet or directly in your injector multiplier table to adjust your fueling straight from your wideband and your target air to fuel. So does everyone know that your air to fuel ratio target in your data log is what you set it to in your power enrichment table?
Mm-hmm.
Yep. End of injection, that's a fairly big area. I can show you what I've worked out so far with the Excel spreadsheet. I don't know if anyone's downloaded the new one in the enhanced mod forum. And all the different maths, just basically what I've tested and what sort of frequency range you can expect to get out of them, what the part numbers are, what the wiring is for them. And I guess I won't get on the topic of MAF versus MAP, but I think we can all agree that, MAP has its place and MAF can have its place as well. There's certain things that MAF can't read, or certain conditions that MAF can't read, but MAP can.
Can I have an example on that? Because that's something that I'm struggling with. I see a MAF as an intake restriction, not something that can control the engine better.
So I guess you'd have to define what both of them are and what they read first. So the MAFs are a hot wire sensor. And yeah, basically it's like a temperature, a hot wire, and when the temperature goes up or down, then it will fluctuate the frequency as well, the frequency output. So you can have atmospheric conditions, just like, humid or not humid. Altitude, how dense the air is just passing over the wire will cool it at a different rate, or, so that will affect the frequency versus MAP, which, the altitude can have an effect, and that's why you got your altitude offset tables for MAP, but you're just monitoring pressure basically. So I guess that's why the OEMs have all gone to MAF now, because you can get more on-the-fly adjustment.
They also adapt to small changes with the engine a lot better than MAP does. Yeah.
I mean, you've got, I guess you have to look at the whole picture and just sort of help map it out so everyone can see it, and I'll do that in a moment. But the MAF is like a third adjustment. So you've got other things that adjust the fuel as well.
So would you say that the main benefit of a MAF is improvement of drivability and efficiency rather than out-and-out performance?
Well, to an OEM, it can tolerate conditions better than a map system would. You know, you can say GM, they can go and sell a Commodore in the middle of the desert, and they can sell a Commodore to someone in a rainforest, and, you know, both of them will have enough leeway in that, and the MAF can pick up the air density and the humidity and everything and change the fueling enough to cover it.
Yeah, can I say one thing about the map versus MAF? The MAF actually measures the direct quantity of air going into the engine, like the mass of the air, so it's able to adjust for altitude, temperature, humidity and all that sort of stuff. So it's directly feeding information into the ECU about how much air is going in, where the map system works on kind of like it measures pressure in the manifold, and then from there it actually calculates. The ECU will calculate from its code how much air will be going in based on assumptions of like what the ideal gas law or something like that.
Yeah, that's pretty much it.
As I found, like even small changes on a map-based system needs retuning, where on a MAF you could say, you know, put on rockers or even like a good exhaust or something, and usually the MAF-based system will actually accommodate for that.
Yeah, when you change, if you do, you know, minor porting or anything like that, you don't have to adjust the VE table because the MAF is telling you exactly how much air is going in, not whereas with a map it relies on the VE table and the map sensor to get that same information.
Yeah, that's right. Like I just took out the bell mouth out of my VR and I tuned it today, and I did actually find there was differences. Not huge, but they did affect the overall like air-fuel ratios that were reading in certain points of the map. So yeah, that's just a minor thing, and that changed it quite a bit.
So that's how I sort of reference the MAF. It's sort of like another thing, another item that can monitor conditions and change the fueling.
Sorry, Nigel, can I butt in for a sec? I just after everyone's thoughts on. It's a popular modification to do a MAFless tune on an LS1, let's say, but in the States that's not popular.
Right.
It's to tune the MAF.
Yeah.
Why would that be? Obviously, you've pointed out the benefits of the MAF now, but why in Australia do people throw it over the shoulder?
Can I answer that, because I know a bit about that. The LS1 that we all get in Australia is the MAF is restrictive from the factory. Out of a box stock LS1, the airflow meter actually restricts the amount of horsepower, and that is why the easiest thing for people to do is throw it in the bin, tune the VE table, say happy days, and they go away. Whereas in the States, they've mostly moved past that generation of engine, and once you get to the LS2, the airflow meter is actually big enough to accommodate the engine from factory. So you get there's no benefit to removing it. So they just tune it in, and that's...
I was going to say they're probably using the card maps over there now versus the round style maps that we all have here.
Is there much success in tuning to a different MAF?
Well, obviously you can get better range. So if I go down in the enhanced mod, so you can see, this is an AT Delco one, range up to about 10,000 hertz or 12,000 there. You got 12 to 14 on the Delphi, and then all the new ones, they're using this one, which goes 15 to 16. So I'd say that the newer LSXs are coming out with the card map. So, I mean, obviously there's the extra range there, so they can just keep utilising it.
The main point is ease. There is no outright power benefit to it, and it's so much easier for a lot of tuners to throw the MAF in the bin and then just tune the VE table like they used to, and that's why they all do it. Whereas if you put a MAF on, then you've either got to find a pre-calibrated MAF table or do it yourself, and a lot of them are so used to doing MAFless that they just keep doing it, even though it may not necessarily be better. But the only benefits you're going to get in keeping a MAF is going to be in drivability and economy, but your outright power is going to be no different at all.
I'd love to have a lesson in MAF changes, MAF scaling and all that sort of stuff. I've got absolutely no idea with that.
Yeah, well, I'm in the same bin, really.
Just going to show you here the three tables. So everyone's got the base injector rate, and you'd have that on all the map stuff as well. And then on these ones, you've got your injector multiplier table. I mean, it's pretty much like it could be a VE table or anything. Mm-hmm. And then we've got a MAF on top, so it's reading when the airflow changes at what frequency they're on the table, and it's just, I mean, you know, by the time you modify your engine at 2700 hertz, you're probably not flowing 7 grams per second of airflow, but it's just a value, really. I mean, you can recalibrate it. There's I forget the name of it. There's a tubular device you can fit into a laminar device, I think they call it. You can fit into it's like a calibrated tube, so you can fit that into your tubing and flow it through and actually get a new table out of your out of the MAF that you're using.
You can also do it by sticking your new and your old one in series and with the data logger. That's how I did the MAF learn code for the Motronics. You stick your new one in front and drive around for a while, and it builds a new MAF table for you.
Yep. So yeah, that's pretty much. So what I did in the enhanced mod was just put in these extra tables. So in the factory, you stop right there, and it enhance, you keep going. So as a starter, I mean, some people like to change the tables. So I mean, I just used the factory grams per second, left it in there, and then I just linearly curved it up after the end of the factory tables and kept it going, so you can see it continues there all the way up to 512 or 510 on the last one. But yeah, it's up to people how they want to use it. There is a lot of the back end code does base itself off MAF, so automatic transmission stuff. The adaptive shift isn't really used because it's still based on map code. It was an old port over. But a lot of the stuff is torque management, especially if you've got traction control and all of that on the VX and VY later models. It will use the MAF stuff for that. But I mean, once you're getting past that there, you can fiddle with these maximum tables and you can cancel most of it out. Right, so end of injection, does that interest people at all?
Definitely.
That's something that's not in the older map stuff, I don't think. Is it?
No, they're all batch fire anyway, so it's...
Yeah, that's right. Yep. So there was a calculator, the new one that I made up, and this is from my head banging against the wall from what I can figure out. But basically, end of injection is the time delay between the valve opening and the injection event finishing. So if you were to set end of injection to 0, well then it would finish when the valve opens. So that's basically so you can put in your cam values there, and you can fiddle with that and basically make up yourself a new table. So in regards to a camshaft, I guess the thing is that duration can increase, and that takes up more of your time. So you can, because you've got so much extra duration, you can finish the injection at a different event. You can shift it up further. And that's probably something that should be tested on a dyno, but I haven't really got access to a dyno up here to see, where...
Could we get back to what the point of looking at end of injection is? Because I don't think a lot of people would understand that. Because I watched a video that sort of explained it very well, in that the whole point of buggering with end of injection is your very low load quality, idle quality, essentially, because on a big camshaft, the inlet and exhaust valve are open at the same time. So if you inject your fuel early, then your fuel is shoving it out the exhaust, and you're getting raw fuel going out the exhaust, and that's why they all smell fuely. Whereas if you make your end of injection later, then by the time the exhaust valve is already closed, then your injector fires, and then all your fuel stays in your cylinder. And that's the whole point of buggering with this at all.
Yep. And the other point too is hot versus cold. Cold start can be a big pain in the butt as well. Obviously, there's minimal point to injecting on the back of a valve when it's cold, because it won't be hot anyway, and you'll just end up pooling fuel. So you're probably better off injecting it closer. So say the factory does it at 408, you might be better off doing it at 380 at idle when it's cold for the first couple of seconds. That'll help it out a lot as well.
So you'd obviously tune this throughout the rev range, not just for idle quality.
Yep, so in enhanced mod, when you go, I'll disguise all of these, when you go in there, so there's a cold and a normal table that I put in. They're RPM based, and there's a scaler there, so you can set at what coolant temp it switches over from the cold to the normal. So
what you got to remember though is your injector. Say you get up to 80% duty cycle, that means for inlet opening, inlet closing, exhaust opening, like you're all the way open during that entire event anyway. So when it fires, it becomes a lot less important at high load because it's always open anyway.
Yeah.
Yeah. Yep.
Yeah, that's kind of like...
The valve overlap at idle is a good point, though. I hadn't thought about that.
And that was explained in the video that the way you get it really good at idle is you run it in real time and you alter the end of injection and you look on your wideband, because more fuel is staying in the cylinder, more fuel is burning, and it alters the reading on your wideband.
I was actually going to ask that. Which way does it affect it?
I forget.
From what I've seen, if you've got raw fuel going into your exhaust, it says it's lean.
Not necessarily. It doesn't change the amount of air coming out. It changes the amount of fuel that is staying in the cylinder. So when there's raw fuel coming out, it may read. It's actually going to read richer when.
But if there's raw fuel coming out, it means that fuel hasn't burnt, and if you've got the correct amount of fuel going in, then it is actually burning lean.
Yeah,
you're right. It'll be rich. It'll read lean, and it will richen up. It will read richer as you get closer to your ideal end of injection event.
Because the oxygen's being consumed, obviously, when it's burning, rather than just being like in a vapor form in the exhaust. So does that kind of make sense?
Yep.
Yeah, that's what I think.
And then you've still got it on the other end, on your intake end as well. If the injection timing out, well, then if depending on your valve timing to when the end of injection is, whether it's going to help atomise the fuel or not, or pool it, or more fuel on your port walls doesn't help. So yeah, that's one feature there that I put in. The factory table is just a coolant-based table. So yeah, you've got some kind of cold start. You can set it at a different time, but there's no RPM, there's nothing like that. So I thought it'd be much better to lay it out like that, and it didn't take a lot of room to do it. So yeah, that's that one. What else can we go through? Has people got questions about anything or something that needs further?
Maybe transmission tuning. We could just a quick touch on that.
So people have got a general idea about how a transmission works, or say in general in the VS or VR to VY they all use the 4L60E in general. So 4-speed electronic. The best thing to probably, if you don't get any of it, some late night reading would be this 4L60E manual. It's the GM manual. It's pretty much everywhere on the internet. You can download it. I think there's a few links even in the forum as well. Yeah. So it takes you through the whole thing from start to finish. You know, how it works, what all the components are, the pump, where the oil flows, when you get into it, even how it changes gear.
Did your brain hurt when you looked through all the oil flow diagrams?
Well, I've had a few transmissions with some problems, and I've had to nut through them before, yeah, so yeah, it does.
My head hurts bad enough when I look at the T5. I can't imagine building one of these.
Yeah. Well, that's where it all starts. It's your pump there. So it feeds fluid. Probably the easiest explanation is your pump makes high pressure. When it gets to the valve body, it goes lower pressure, and you'll see the 0 to 90 PSI mentioned in all the tables and things that you can change in the tune. And the 0 to 90 is basically in your valve body. Things to shift your components. Yeah, so, but this manual here is what you can pick up if you want to see what's inside and how things connect again, you know, which COTS packs are what. So it runs through everything from park, you know, every single gear, what happens, gives you a full list of what's applied in what order. So, I mean, it's the go-to manual. So, you know, crux of it, I won't go through that. So you got your gear shifting there. There's cold and hot stuff as well, which is set on fluid temperature, obviously. I guess gear shifting and how to tune it would be one question. So, I mean, some other people might have a better idea of this, but from looking at code and testing stuff, this is what my best overall thought of it is. Let me find the other tables. Ramp delay and pressure delta. And you kind of nearly need a diagram to show the process of it all, but and you've got all these other tables, and it's like spark, you know, you've got base spark, and then you've got intake offset, and you've got coolant offset, and it's all these things that offset each other. So I wonder if I can do, that's your base table there. And you really need a data log too. I wonder if I've got a data log somewhere. That'd be the best way to show it. Something I didn't pre-plan for. But anyway, we can start with this anyway. So when a gear shift happens, it commands the gear shift to happen. So 1 to 2, you get the solenoid shoots the 1 to 2 valve, which changes where the oil goes in your valve body. And there's a mod time. So it's basically a time period that's set when everything's got to happen. So an increase of oil pressure, so you get this, so it increases 3 psi when shift happens. Then it's got a ramp pressure, and the ramp delay time specifies, so if you're here in a 1 to 2, 0.3 seconds into your shift, it will then add 39 psi extra. So when you're looking at a data log and you can see, everyone knows what slip RPM is on the item in the data stream. So it's basically engine RPM versus the output shaft RPM. The code works it out as that and looks at the difference, so it's the difference. So obviously if you've got torque converter slipping or a clutch slipping, or which could be caused by a leak or worn out clutches or anything like that, but you can look at the spike in the log with the slip, and you can look at the time periods when the slip is happening. The items to log would be gear ratio, because you can see there's requested gear, gear ratio. So you'll be able to see it request gear ratio changes. You'll see the clutch slip go up, and based on the whole time period, then you need to, if it's, say, at full throttle, an acceptable time period on a normal transmission would be, a 1 second shift. But if you're getting, say, a 2 second shift, well, then you're obviously getting up near this limit. Then you need to look at ramp pressures. Do I need to change the delay time? Do I need to get in earlier or later? If you've got a high performance transmission, it's obviously going to shift quicker. You don't want your ramp pressure going later, because then you might just bind something up. Depending on what gear it is, so if you're going into fourth gear, well, then you've got, the bands locking up. That's where all that diagram comes in handy to see what's happening in what gear. So you can work out the whole event, you can work out what needs to happen, you can see what's happening and what you need to change to try and stop bad stuff from happening. Hopefully that's a point in the right direction.
So all the shitbox Commodores that I've ever had come in the workshop with a shift-kitted or modified auto that thump and bang.
Yep.
It's doing that because they've been poorly tuned in this regard?
Can I step in there a little bit? A lot of people don't really know this, but on a 4L60E, there's a little hex nut that alters the overall. It manually alters the pressure in the box. And what that's actually for is, from factory, they use that to calibrate. When the ECU is commanding 90, then they calibrate it so it's actually 90 in the box, for example. And then an auto shop can go, the pressure's a bit low in this box, I'm going to screw it up. So independently of the calibration, they might screw another 10 psi onto that screw. So when the ECU thinks it's only 90, it's really 100 now. And that's when you screw it around probably half a turn, and you'll start getting it thumping into D all the time. And that's sort of what a lot of the problems are. So if you get one that's been screwed up real high, then it's pan off, 3 bolts off, where those 3 bolts pull one of the pistons out, and then just behind on the back of one of the solenoids is a little hex nut that you can back off.
That's the force motor.
Yeah.
Be talking about, and the force motor is what basically all this works on. So the force motor, and you can actually see the table here. So it's this one here. So the force motor, that's how it translates it. So the force motor in the valve body at 0 psi, it's at 1 amp. It actually goes to 96, but the calibration's all the same, as you can see, compared to 90s. But yeah, 0.2 of an amp. So it just changes that to give you delivered table, this one here. So when you're modifying this point here, well, it's just changing the amperage on that force motor to deliver different oil pressure on your valve body. The other thing too that I've found is when you get the hard shifts is that they've drilled the valve body plate. So you have little holes in your valve body plate for 1 to 2 shift, 3 to 4, 2 to 3, TCC lockup. There's also another mod on the TCC valve in the valve body where there's a little spring and they put a big spring in so that basically there's no PWM, it just locks up. So you'll come up to the period where the torque converter's going to lock up on the highway and it'll just go from 0 to 100 and bang straight in. They do that for various reasons because the PWM does wear out the bore in the valve body, so they put the spring in there so it just doesn't operate. So your TCC's either on or off, like in some of the older transmissions. But yeah, the holes in the valve body, plenty of shops do that. They just get a new valve body plate, drill a few holes, it makes it shift really hard. You get all sorts of problems with that as well if it's too big because you can get gear overlap, like second to third gear when you got the band on and you're letting go of the band in going from second to third, you can get a miss event from the clutches going too quick and the band not releasing quick enough, or the band releasing too quick and clutches not engaging quick enough, and then you get burnt stuff. It's all a balance in an automatic transmission because you got fluid going everywhere.
Of course, there's another problem there too, Nigel, is that the very time that some tuner comes along and starts playing with the transmission settings, it often can void the warranty in many of these transmissions. So got to be very careful what you're doing. It pays to get permission from these people who rebuilt the thing, and if they're okay with it, that's fine. But otherwise, they can certainly blame you for what goes on.
Yeah, and a lot of the time they built it to not need any playing within the tune, because they're like mechanics. They built it to run as a performance box or whatever out of the box without running the factory force motor tables and stuff. Yeah.
Because the other thing too, which is rather strange, is that for many, many years, of course, these transmission guys have been making these mods long before we had the software.
That's right.
And yet you never come across a transmission guy, I haven't anyway, the guy that's doing mechanical work and he's got the software as well. I mean, you can't beat that combination, but I've never seen it.
No, that's right. I guess it goes the same for engines and lots of other stuff, and the mechanics. I guess because it's getting so diverse now as well.
Actually, there's one... Sorry to interrupt you. There's one very common problem that I come across, and I'm sure other guys on here have too, and that's the thing called Code 68. And Code 68 on the early transmissions is basically a component slipping in the transmission. And Holden were aware of this. It was a design problem from the engineers. They made the tolerances far too small, and the box only had to wear, or the torque converter had to slip just a little tiny bit, and all of a sudden the engine light comes on, you've got Code 68. Well, the transmission guys love this. I mean, this was a $2,000 job for them. And I used to approach some of these transmission guys and say, listen, I've got a good fix for this. I've got a Memcal here, cost you $100, and save the customer a lot of money. And he would say, listen, we don't want to know about that. We want to pull the box out. We want to make $2,000 on it.
Yeah.
Yes, that's what happens, yeah.
But That's what Holden actually did. In the later calibrations, Holden disabled code 68 themselves.
Yes, that's quite true.
It's not being dodgy or anything. It's Holden's fix.
Yeah, that was late VR, I think, wasn't it? The VR. Yeah. And I heard as well, this was actually talking to a guy in the States, I heard as well that Australia didn't actually have transmission technicians. That was still done in the US, so it was a lot of copy and paste.
I believe that, yeah.
Yeah, the engine side was sort of the specialty in Australia, so the validity of that, I take that with a grain of salt, but yeah, that may be the case.
Well, also, what about all these fan temperatures coming out of 110? I mean, any Australian wouldn't design that for our country, you know.
Yeah, I thought that was ridiculous.
Well, I think a lot of the early Buicks ran 80 degree thermostats, didn't they? Early on.
Oh, yeah, they would have.
In the 50s and 60s, so that was the factory item.
And you can't even edit that in an Alloytech. There's nowhere in the Alloytech tune that you can edit where the fan comes on, because I tried to do it on my bloody own and you can't.
Yeah. Yeah, so, I mean, a lot of this stuff is still beyond what I've worked out, but...
So one other thing that I could give, a piece of advice I can give for people looking at this sort of stuff on For All 60Es is don't trust your dipstick to be gospel, because they like to be about 500 mils over full. If it's slipping, you can put 500 mils of oil in it and it doesn't slip anymore.
Yeah,
I can vouch for that
as well. Yeah. I've seen that.
I think the 5L40E, when they changed to the VZ, I think it's no longer a dipstick, it's a bolt in the side, so that they can actually keep the right oil temp, like filling a diff.
Oh, yeah.
Oil level, sorry.
Yep.
So, yeah, I think that fixed up a lot of the 4L60E problems. So, yeah, I guess the best thing with automatic transmission stuff is to actually data log it and see what's going on first before you change anything. Yeah, see what the shift time is. You can work that out with the gear ratio and how it's slipping. It's sort of more pretty much like a bell curve. You can see the clutch slip and then engage.
Sorry, just with that force motor adjustment in the box, would it be advisable then to put a pressure gauge on the box and make sure that what's in the calibration matches what the box is actually doing?
Well, that force motor is different to the bolt on the side of your box is measuring your pump pressure. Mm-hmm. That's between your pump and the manual valve where you hook your linkage up to.
Yep.
And then beyond that is your valve body pressure. So
the force motor does change the pump pressure too, the way it works as far as I've seen. But the catch
to a degree,
the biggest catch is the ECU doesn't actually know what pressure the box is running. There's no pressure gauge. All the ECU knows is 0.68 amps is supposed to be 90 psi, because they're assuming that the bolt on the back of the force motor has been calibrated correctly and not been fucked with by some happy auto technician.
Yep.
So it is advisable to an extent to make sure that you're not running pressure through the roof, but you'll find that there's guides online as to what your pressure should be in D and neutral and R with a gauge. And I've had a gauge on the side of a few boxes to actually look at that, and it does go.
It's in that doco, yeah.
Yeah, it goes through the roof in reverse though, but that's normal. But I found all this out the hard way, because I actually made a transmission controller of my own and eventually gave up and decided it was so much easier to use 11P when that came out.
It is in this document. Like there's all your valve body, what all the valves do. If anybody can't find it and they want a copy, just let me know. It's in here somewhere. But, I mean, yeah, checking, if you've got a problem, check that pressure and compare it against the GM table in here. It's obviously, if you've got a piston that's leaking in a clutch pack, well, it's obviously going to show up on the pressure gauge when the pump's got no pressure or something like that. Or so it is one indication for sure. Cool. So anyone else got any other questions about that one?
Yeah, do we need a PhD for this?
Yes.
Well, I mean, we're trying to do stuff that's, like transmission guys. I think from one guy I talked to, there was 5 guys that was their full-time job, just doing transmission calibration. They had all sorts of stuff hooked up to transmissions over there, and, they'd be driving it out and the test fields out there at -20 with the head out the window doing data logging, just to get a reading down sub-zero, and then, running out in the desert to get top level stuff, and then they'd put it in one of those test rooms with the heaters and the freezers in them as well to do precise temperature control. Yeah, I'm sure they had plenty of tricks in the book to do stuff. And I guess sometimes it comes down to money too. And what top level people you've got pressing you to get this product out. Cool, what else haven't we covered? OSE plug-in for VS to VY. Is everyone good with that? A quick demo of that?
Yeah, do a run over of that. Is it similar to 12P or is it different?
Yep, so you just download the plug-in zip file, drop it into your
Tuner Pro.
Documents, Tuner Pro, plugins, drop in the DLL file into the folder, and so all the enhanced stuff when you run, I've got it closed, when you run Tuner Pro, I've just got it turned on here, it'll show up down the bottom, so VSV6, $1.51, 1.4 version, so the version changes when the enhanced version changes. And you set up your COM ports and that as usual, so preferences, and you select the plug-in in both boxes, config your COM port. Antis has added in this to help deal with BCMs and clusters and things to stop the chatter on the bus. I think last time I tested it, it works on VXVY Flash as well. You can set it to VX, I think, and it will help get rid of the chatter, although the last enhanced ADX that I released works flawlessly on the cars that I've tried it. You don't get any bad data or anything, you get a good straight connection first time. And I was just, there'll be other versions of ADXs coming out soon. I've just added in an extra tick box in case you're not using a BCM, because otherwise it tends to hang sometimes, waiting for the chatter to turn off. Cool, so that's that. MQL ID tool, OSE Flash tool. People need any info on that.
What is it?
So it's a tool that VL400 made, and ideally just for the VX and VY Flash PCMs. Mm-hmm. I'll connect up on the VS one I've got here. So you can go into preferences, select your vehicle. So if you're on a Flash PCM, you can do that. And so this is basically for pulling the bin file out of the Flash PCM and uploading a calibration, or you can essentially download a bin off the Flash PCM and upload it to another one if you want to clone a Flash PCM.
There's a lot more to actually use it for if you do, depending on how much you use 12p and 11p, because I use 12p and 11p more than any other thing, and every single vehicle I tune, I'll use this flash tool, because you can make a bin up and then flash the calibration in using this tool before you start, and then at the end, when you're ready to burn it, then you open this tool and get the full bin out, and then use the bin out of this flash tool to burn back to your memcal to give to the customer. And if you need to edit any of the flexible output items or the ALDL data stream of 12p or 11p, all of that is in this tool. So if you're using 12p or 11p, you will be using this flash tool a lot.
Yeah, you can also use it to migrate to different versions as well.
Yep.
Yeah, so I've used it a couple of times. Yeah.
Yep.
I found it a handy tool also to suss out what is going on with, like, say if you have ECU that's stopped working for whatever reason, you can check if your MV RAM has gone wrong or something, and I've used that to check it, where like Tuner Pro wouldn't do anything. This allowed me to see that some of the data, it was sort of working, but it was corrupt, so yeah, it was useful.
Yep.
So
just to clarify, you're taking a read of the bin via the ALDL?
Yep.
Yep.
So on Flash PCMs, you can get the whole bin and you can upload a whole bin, or just upload a calibration part of the bin back to the ECU. So
this thing will actually get the full bin of anything from VR, all the VR and onwards in the map-based PCMs. This will get you the full bin.
On VS to VY, it's just the cal area. Well, it does get you a full bin, but you're actually getting what's in RAM contents at the time. So your calibration part in the middle of your bin will be fine on a VS to VY, but the other stuff will just be nothing worthwhile. So you wouldn't want to upload or burn a get bin off of VS to VY onto something, because it just wouldn't work. All the code won't exist. You've just downloaded what's in RAM. So yeah, the Flash tool will pick up the enhanced mod as well. So if you want to see that it connects, if you're having trouble with Tuner Pro, it'll tell you that and what version you've got. So yeah, that's pretty much that. Crux, I mean, there's plenty in the tool. VL400's put in ALDL logging stuff. I've never had to use the Flash PCM recovery. So yeah, it's a very handy tool, and it's very small. It's just the one exe file, so keep that on hand for sure.
Very, very handy for those aftermarket memcals that are scrambled that you can't actually read in a burner. You can, a lot of the time, read it out using the flash tool, because the ECU is kind enough to decrypt it for you, and you're just pulling it out of RAM.
Yeah.
So,
I think we've got a solution for that Crow Cams memcal we're looking at, Vlad.
Yeah. Yeah, we'll have a look at it.
That'll work for pretty much all of those, the Crow Cams memcals. You just pull it straight out with the flash tool, because it depends though. If it's a VN based tune that they've burned onto it, there's no 8192 board ALDL, so you can't use the flash tool. But if it's based off of VR or later in the program, then you'll read it straight out.
Mm-hmm.
We can always give it a shot.
Or even on the latest, on the VS to VY, you can still do the get bin, and you'll be able to open it in Tuner Pro and look at the calibration area if you can get the bin ID right.
Yep.
Because the cal part will still be correct.
I guess, Gareth, have you got the memcal adapter for the programmer?
Definitely, yeah.
Yeah, you could just read it that way.
No, I've tried. It wouldn't.
No, there's an address scrambler underneath. I've looked into this to play around with decrypting one myself a bit. What there is that there's a little intelligence little chip. I don't actually know what to call it or what it does, but under the memcal, it looks at what address lines are being read, so you have to actually read the EEPROM in a certain order, and as you read each pin, it will remap it underneath and allow you to read the next bit. So it knows what order an ECU reads the bin in. It always looks at the reset vector first, which is at the very end of the bin, and then it reads backwards, whereas an EEPROM will start at the beginning and read all the way to the end. So it can detect it. It can detect that, and it will leave it all scrambled when you're reading from start to finish, and it will only unlock the correct address lines if you've read the reset vector first and then gone to the beginning of the code and read it in the order that an ECU will read it.
What school did you go to learn all of that?
It's called head banging. Why the hell can't I read this memcal?
All my life. That's exactly it. I actually managed to read enough of a memcal by looking at where the reset vector was and putting that offset into the burning software, and you can read that bit first, and that'll get you a little bit of the bin unscrambled, and then you can figure out where you need to read next to get the next bit.
Jesus Christ.
It's a mind bend, I tell you that. The easiest way is just to plug it in and use the flash tool.
Yeah, just listen to that.
There's a company called EVC which make a lot of they make a lot of the I think they make WinOLS among other things, but they have a whole range of hardware encryption sockets for protecting things. Key 101 is one of their more famous one. And I spent quite a while trying to reverse engineer one of those, and it ended up being that their version actually just looks for the timing of the toggling of the OE line using the basis of an EEPROM programmer will toggle the OE line between reads, whereas an ECU won't. And managed to decrypt a whole bunch of the stuff protected with their bins using that way, because their modules have an individual encryption key per vendor that they sell the things to. So just because you if you reverse engineer one, it won't work for one of their modules that they sold to someone else. They were real painful, those ones.
Yeah, this leads me to a question. Why would Crocams try to protect their calibrations if it's so terrible?
Yeah, well, but
they're not the only one.
What you find is the worse the tune is, the more they try to protect it.
Yeah, I agree with that. Yeah.
Yeah.
That's why.
Like a dodgy builder.
Jeez. Well, I think I've covered most of that stuff. It's definitely a good session starter anyway. I guess people will ask more questions afterwards. We can go from there, but that was the idea, to get something happening, and then the people that are actually keen get more information than maybe banging their head against the wall or having trouble finding it on the forum or whatever, and it helps people use the enhanced mod. Helps. I mean, maybe one of the other guys can do stuff on 11 or 12p as well. Not sure whether Ryan might have bench set up so he can demo stuff on that as well.
Yeah, I've actually got a question for him when we do one.
Yeah, so
I'll ask it here if you want, because a few of us use the 12p a lot. Yeah,
well, I know that I sort of not me directly discovered a problem, but Ryan picked up on it when I was doing the tuning on my VR a while ago, that because I'm at a higher altitude, the I think it was the ADX or something didn't scale the log, the table that it logged versus what it would actually do in the ECU. So every time I logged, I'd only get up to 90 kPa when the ECU would actually scale it to the 100 kPa within the actual ECU.
That was actually added into 11p version 104, I believe, because because of that same reason. The ECU scales the map, whereas the ADX was just reading the raw map.
Yeah.
But the N11P104, it is actually scaled now, but I'm not sure whether he edited 12P or not.
Yeah, he said he did it, and I got an updated ADX, and then version 1.12 came out, which already included the fix that I'd got beforehand. And I noticed that sometimes it works and sometimes it doesn't. Like in the recent days I've been tuning it, it hasn't worked. What I've had to do is copy the 90 kPa and 95 kPa row column and chuck it into the 100, and then I'd get an accurate log the next time round. But if I kept just putting in what it was logging, eventually my tune would get further and further out every time I logged it. It'd get
that's definitely something for Ryan.
Yeah, I'll have to pick his brain on that one. Yeah, and the whole the baro as well, like the barometric pressure. Sometimes I get 104 when I start up the key, which is odd because that's what happened when the first time I got my once he tinkered with the ADX and said, yeah, give this a go. It would always just default to 104. Like, I guess that's the maximum value it can be, and then.
So it's almost like you need a offset table in the ADX, the same as your ECM.
Yeah. Yeah, so what it was doing was going to 104 most times, and sometimes it would just give me the actual barometric pressure, like 96 or whatever, and when it would give me the actual one, that's when it wouldn't do it properly. So I don't know, it's like it's half work and half not. Sometimes it works and sometimes it doesn't.
Sounds like a bit of a code bug to me.
Yeah.
Filtering could be.
Yeah.
You running a turbo there?
Sorry?
Are you running a turbo?
No.
NO?
NO.
Because there was, I remember that there was some code in there for the forced induction where it wouldn't. You had an option of not recalculating barometric pressure during a run. There's an
option to be during a run or on key on. Mine's set
just start.
Yeah, just start. Yeah.
Okay. Well, if you're NA, why not? Have you tried it the other way during a run?
Yeah, I might do that tomorrow. I might give it a go just to see what happens.
It shouldn't have any negative impact if you're not forced induction.
Yeah, it should be all right, I think. I mean, I do open full throttle enough times for it to update it, so it should be all right.
Sorry, officer, I was just giving my ECU some good data.
All right, cool. Well, no one's really got anything more.
So can I have a question for Dick? What's this 30 hertz logging you were talking about on the forum that you were going to talk about?
Yeah, okay. We did some testing today with one of our members, Peter Callow. I'm not sure if you know him. He's 0081. He actually lives very close to me, and we did some tests today, and what I discovered is I wasn't aware of the offset in the enhanced programs. The offset's only 1, whereas on the earlier programs there's an offset of 3. I don't know the reason for that, but maybe Nigel can explain that. As the payload, remember that the body length versus the payload.
Okay.
And in the earlier versions, which I've been more aware of or used to, with the coding I've been playing with, it's always been an offset of 3, and of course I tried to use 3 and it didn't work. I had some problems with it, but I've overcome the problem. I've actually gone back and used the same offset that you've been using. And
the enhanced should be the same as factory. I mean, other than putting things in, swapping the items out of what's actually in the payload, there's nothing changed to the actual.
The 3 should be the standard ALDL message header. So
yes.
1, that's interesting. If you're only saying 1, maybe with the flash tool capture some of the packets that are coming through and see what's going on.
Well, actually, I mean, Nigel, that is Nigel's program, and the offset is definitely 1.
It's not something like the OSC plugin stripping off the header bytes or anything.
No, it doesn't do that. It sounds more like maybe. See, the offset only changes where the body of the message, where the first byte is. So you could technically use an offset of 0 and just move all of your items up a couple of bytes in your addressing.
So you're saying that the first data byte, address that as byte 3 in the body to overcome. Yeah, okay.
Exactly. It sounds to me like there's something more like that going on. So it's different authors of different ADXs. They may have just done it differently.
Because I did notice that on the very early ADXs, which were called something like $6060A, you might recognise that number. They were very early ADXs. Now all of those are all have the same offset of 3, and just the more recent ones that I've been looking at are 1. So it doesn't matter. I've certainly have solved that particular problem, so I'm sort of continuing. But what we're basically doing is we're actually just shortening the actual string up. That's all we're doing.
Logging what you want to log.
Yeah, exactly. It took a while to work out how to do it, but I mean, once it's fairly easy once you've learned how to do it. And I've got to talk to Ryan and see if he'd be kind enough to add it to his Flash tool.
So you're kind of making your own message 6 kind of system.
Yeah, exactly. Well, it can be anything. You can actually could be a message 6, 7, whatever you want to make it.
Yeah, but a short custom message of nice and fast, just the data you want.
Yeah, well, I'm actually getting 30 hertz out of it, and of course, when you're looking at logs, it certainly helps, yeah.
Yep. So, yeah, well, that's something that could be better with, say, knock, type things, which would be too slow.
That's the other thing I wanted to mention, too, is that I've noticed... there was a post up about knock sensing with regards knock sensor and the knock counts, and I've looked through a lot of the CalMaker stuff in the VY, and then there's no logging of it at all. At 0, there is no log counts, and I'm very curious to see if we can actually find that in the code.
As in, like the knock counter, rolling counter that I've added in.
Yep, just the rolling counter. Yeah.
The only thing that I've added into the Flash ones is the MAF tables, MAF extension. So other than that, it's factory, basically.
Yeah, okay, yeah. But because what's strange about it is, as you know, most of those tables in the VYs are using knock counts, for their noise levels and background noise levels, so...
it does have more options, plus it's individual banks as well.
I guess what I'll have to do is need to go through all the memories I can find and see if I can find something that looks like knock counts, that's all. But it's very difficult on the bench,
Cool.
But I'll be sending you that program very soon, by the way, too.
Cool, yeah, we'll definitely have a look at it.
Yep.
No one else got anything else? Otherwise...
let us know where you put this recording, because I dropped out halfway through.
Yeah, that's all right. It'll probably be YouTube, I guess. Because Camtasia drops it straight in there. So
yeah, everybody was there, and all of a sudden everybody wasn't, and I nearly threw my modem through the window. That'll be handy.
Actually, that's one thing. Does Camtasia actually record your own voice through the microphone? Because I can't actually hear my own voice. I can only hear you guys. So if I was
I've told it to record
inputs as well.
Yeah, I think it's in the options here. Tools. There was an option there before I started recording to actually record the all streams. So yeah, fingers crossed we've got everyone.
If not, otherwise you just have to do a voiceover afterwards.
Yeah.
I certainly think this has been a fantastic thing. I think it's worked way better than what certainly I expected. And just while I've got the microphone for a sec, I'd just like to take this opportunity to thank you, Nigel, for taking the time to do this. This has been great. And for everyone else's input too.
No worries.
Yeah.
I was definitely nervous myself, you know.
Yeah, we all bite.
Yeah,
All right,
thanks,
guys.
Nigel. I've got a whole stack of VS ECUs and never actually looked at them or anything. So, it's sort of opening my eyes to the whole world of MAF and auto gearboxes.
Yeah, well, I definitely won't say that MAP's not out of the equation. I mean, it's definitely something that we'd all like to do on the VS2VY models. So, I mean, it's yeah. And there still is a lot of map stuff left in the code that rolled along from the earlier models. So, I mean, just a matter of knowing where it all is and what does what, and seeing if we can make it all work, or whether we've got to rewrite a whole new thing from scratch. But yeah, time is the key, and a lot of us don't have a lot of time, so it's slow, unfortunately.
Going back to the MAF versus MAP, my general consensus was that the MAP system is faster responding. Is that true, or is that more just an urban myth?
That's been my experience as well. You'll find on, say, a factory Ecotec, if you flatten it, then there's a certain amount of responsive there, like a little delay before it'll actually go, and possibly able to be tuned out. But that's because of the, as far as I know, is the delay between when you flatten it, it sucks all the air out of the plenum, and it has to make that wave has to make it all the way back to your MAF, and then your MAF can start reading the air and the fuel increases. Whereas if you have a MAP sensor, it will read instantly the drop in pressure in your plenum, and then the fuel gets injected extra straight away. But anyway, I've found if you take an Ecotec and throw a map-based computer on it, your throttle response is a lot better.
Yeah.
So I've found out of experience that, yeah, that's true.
Yep, it's all in the placement. A map's going to be closer to where the air goes in, obviously.
Yeah.
I mean, there's a lot of BT and up. There's a lot of filtering stuff you can mess with if you want to with MAF. So you can make response different. That's other than DE or AE.
So is that kind of like reading the TPS movements and then sort of
filtering it?
Yeah, and anticipating what will actually happen after?
Yeah, there is that stuff. I think it was VT and up. They put that in. Yeah. So yeah, it's kind of like TPS. You can fiddle with the filtering and make it faster or slower. Because most filtering works on, it's got another item and it filters off the real item to make a second item. And how fast or slow it updates that second item is based on what settings you change, what standard settings you change or hard set settings you change. And that's sort of the things to do when people say, their auto transmission slips after they put a bigger throttle body on. Well, obviously because you've compared the new throttle body to the old throttle body, your airflow, you're flying more at lower, so it's expecting a response from zero or whatever idle airflow is up till full throttle is now 0 to 20% or whatever it is compared to 0 to 100, so that whole response time's gone out the window and everything's out of whack,
Same goes for forced induction. It's exactly the same for forced induction. Even on the old Turbo 700s, it's the same. If you're on boost at 50% throttle, you've got a lot more torque going through your engine, but everything's calibrated to back the pressure off at that point, and then you get slipping gear changes.
So yeah, I think it's in the older ones as well. You've got these decreasing and increasing filter coefficients, transmission filter coefficient from the factory. Most of them are near 100. So the transmission side that reads what pressure to give it off the tables, and that is basically what is really happening. But that's a secondary effect to the actual TPS filtering. So if the TPS filtering is slower, then, it's only going to read what that's going to read. It's sort of like a third level filtering. So it would be the main filtering. So, increasing the throttle, you want to make that respond quicker with a big throttle body. Whereas at the moment it's sort of 50, it's on the margin of,
I was going to say a few words about bench harnesses. And I found through the years you can learn an enormous amount on the bench.
Yep.
For example, something very simple is you'll get hold of the throttle one day and just move it, and you'll notice the injectors will fire just by touching the throttle. And a lot of people don't realise is that as you move that, it's putting like extra injection pulses in at the same time.
Oh, I have seen that.
Yeah.
Yeah, it's interesting. I think on a really old Volkswagen Type 3, which was the first production cars to ever have EFI, I remember seeing that, and it was pretty cool. You just turn the throttle and you hear the injector sort of like pulse.
Yep.
Even if the engine's not running on those.
Yeah.
Was that an L-Jet?
Sorry?
The Volkswagen Type 3, was that an L-Jetronic it used?
D-Jetronic, the first. First generation. So yeah.
Yeah. Okay.
I just threw up in my mouth a bit.
Yeah, I thought L-Jets were bad, yeah. Well, it could be worse. It could be K-Jet. I worked in one of those a while ago.
Actually, the D-Jet wasn't too bad. It was kind of similar to like the 808. It just had a map-based system, and that was pretty much it. A TPS, temperature sensor.
Lack of fault codes.
Oh, it had no fault codes.
Lack of a processor.
Yeah.
It had
it was an analog system.
Yeah, I counted, get this, 12 transistors. That's high tech.
You want to raise the rev limit? Well, you change this resistor here.
Oh, God.
Yeah, they were only about the size of like, how big? They were probably like 300
a small
mil.
Volkswagen. Yeah.
Yes.
So you go around to Barney Rubble's place to ask for the ALDL cable.
It's funny, it actually has the diagnostic plugs on those cars, but they were kind of like a complete car diagnostic for like checking shorts, like if indicators work. It didn't really tie in with the ECU so much, but they were pretty big. They were about a little bit bigger than the 424 ECU, probably a little bit bigger than that. Yeah, but they were dumb ECUs. They didn't really. They're just an analog computer. But that was my first experience with like EFI. Yeah, it was certainly better than Carbies, that's for sure. It started first go. That was a big improvement.
Yeah, well, I don't know. Today I had to move both my GTVs around, and neither of them have started for a few months. And my 12P injected one. Turns out my NVRAM has passed its use-by date and wiped itself in the last 2 weeks. Whereas a carbide one that hasn't started for a few months either, just had to crank over a couple of times to let the mechanical fuel pump get through, and then it rolled into life. It took me an hour and a half to get the EFI one running.
Wow.
Yeah, I had this VP, just a spare parts car in the yard, and it was sitting there. I had the fuel in it was probably 3 years old as it was, and it was sitting in the yard for a good 4 months, and I just had a lawnmower battery sitting in it. I kicked it, just on like half a revolution of the engine, it fired up straight away. Yeah, so I reckon EFI is better.
Yeah, 99% of the time it is, but when you start breaking out oscilloscopes to work out why your 35-year-old car won't start, then you got to scratch your head a bit.
Yeah.
I had a question for Jamie. Are you still there, Jamie?
Yeah, I'm still here.
Yeah, what's that? On my screen it says Jamie Turner wants to show video, accept all videos on this call. What does that mean with that one?
That's a Skype thing. It means that I clicked my webcam and you have to allow it to look at the webcam. But that's been off for hours now, so...
It's on my screen. If I click that now, what happens? I'll click it now, see what it does.
Nothing.
Oh,
No,
okay.
Nothing will happen now.
Yeah, no, I wasn't sure.
It's just left over from when I clicked the button at the start of the call.
Okay, very good. Yeah.
Cool. All right, guys. The only thing I forgot to mention was in the VY and the VT, the new fuel cut. So the rev limiter is now 1 byte code. So it's basically means you can go as high as you want.
So we're no longer limited to 6,375 RPM.
No, so you're just limited to the PCM speed. So I think if you went. Yeah, 65,000 revs, that's your limit now.
Do you know what it will actually do up to? I mean, I've with these the Motronics that I play with, I can get them to just the other side of 10,000 before they start missing counts. But they're doing a 60 minus 2 count, so they're probably going to drop out a long time before one of these.
Yeah, you'll lose the data stream on most of them at around 7 to 8. And not long after that, you'll start dropping out.
I know an 808 is supposed to be able to do up to about 9,500, isn't it?
Yeah.
I'll be able to test that soon. I'm a couple of weeks away from getting my 10,000 RPM motorbike engine running on 808.
Yeah, I was seriously considering converting my bike over to an 808 until I realised that the rev limit wouldn't cut it.
Oh, jeez.
Cool. All right, well, I might stop the recording at this point.
Yeah, thanks, Nigel. Thank you very much.
Okay.
Yeah, it's been good.
It's all right.
I look forward to the video so I can actually see what happened. I can't believe that.
Fail. Hopefully
Yeah, pretty happy about that. Yeah.
Yes, so good night to all.
No worries,
Thanks.
Richard.
Thanks again.
Yeah, thanks.
See you guys.
Yeah, bye.
See ya.
Bye.